Welcome back to Mr. Lamb's Science Corner. Once again, we're still here at Mazama. We're shooting like 4 different demos, one after the other. This one has to do with eddy currents. And let me write that down because I forgot to do that. Sorry about that. Okay, so we take a look at eddy currents. Okay, and basically what an eddy current is, if you take a metallic conductor and cause it to be in relative motion with a magnetic field, and quite frankly it doesn't matter if the metal is moving or if the magnet is moving, as long as there's relative motion back and forth, that it will set up an electric current according to, I believe, Lenz's law, L-E-N-Z-S, apostrophe S, and it can cause some resistance to the motion, and people have been using this for electromagnetic braking. Instead of having physical parts touching each other, wearing on each other, you can have it moving close to but not touching each other. And if you turn on an electromagnet, it will cause heat, and you'll throw away some energy, and therefore it will slow the object down. And so you could do some electromagnetic braking and not wear out any parts, as long as you don't get things too hot. And so to show this, I have a piece of copper that has a channel cut out of it so you can see it, and I'll take a non-magnet and it just goes right through. You can hear it hit. Okay? If I take a magnet, you can see it go down, and it doesn't hit anywhere near as hard. Okay? So it will go through. It will, because if it's not moving, you're not creating any eddy currents. If you're moving fast, you create high eddy currents, and so you can have slowing. So if you want to use this for like car brakes, you could slow way down using the electromagnetic currents, but that last little bit you're probably going to have to use friction, because it won't necessarily stop you completely. Okay, but and remember, this is copper. This is not magnetic. If it was magnetic, it would stick to the thing. Okay, but it will slide through and resist that motion, as opposed to non-magnet, which just goes zip right through. And then you can see that the magnet is attracted to the non-magnetic. So I'm not going to hit you with a whole lot of discussion about eddy currents, but certainly suggest that you can look it up on the web, and they can do a far better job than I can in explaining it, depending upon what level you want. You probably don't want to spend a lot of time talking to your students about Lenz's law and all those other things. Okay? Thank you, and we'll see you next time.